This is the Precalculus mid 4th 6 weeks exam 2017. This exam covers basic arc length formula applications and also basic trigonometry. As far as tools for this exam, we have we call it ACP formula chart. Here's the relevant section that covers the special right triangles here, and also below the reciprocal identities. We will use those, and also a TI Inspire CX calculator. So those are the things we're going to use. Problem 1, the measure of angle A in DMS units is 46 degrees, 45 minutes. What is the measure of angle A in degrees? Well, the obvious answer, if you're really not paying attention, would be to choose answer choice A, but that's not right. What you need to do is we're going to take those 46 degrees, and in order to convert these 45 minutes into degrees, we need to multiply by, we have 60 minutes in each degree. And so degrees are left out when you cancel minutes over minutes. So our answer is going to be 46 plus the fraction of 45 over 60, which when you put this in the calculator, you're going to get 46.75. So 45 minutes is 3/4 or 0.75 of a degree, just like 45 minutes would be 3/4 of an hour. So that would be answer choice C. Next, 2, the measure of angle B is 135 degrees. What is the measure of angle B in radians? The basic identity we need to use for that is we should know that we have 180 degrees in pi radians. And so to take this 135 degrees and convert that 135 degrees into radians, we multiply by whatever cancels out. So we got to put this 180 degrees at the bottom like this. At the top, and then numerator, we put pi radians. And so what we have is degree units cancel, and so what we have is remaining 135 over 180 pi radians. And what you're going to get is 3/4 pi radians, and just as a calculator, what that would look like is, I won't even do it. If you put in a calculator, you'll get 3 pi, 3/4, or 3 pi over 4, and that would be in radians. So our correct answer for that will be answer choice C. Next, the measure of an angle is 7 pi over 9 radians. What is the measure of this angle in degrees? Well, it's going to be just instead of multiplying by pi radians over 180 degrees, we would take the 7 pi over 9 and multiply it by 180 degrees over pi radians. And so we have cancellations, and what we end up with here is 7 times 180 over 9. And I think that simplifies to 140 degrees, but just to be sure, we'll take the calculator, and we take 7 times 180, and we'll divide that by 9. We get, yes, 140 degrees. Which is answer choice D. Next, problem 4. A circle has a radius of 10 centimeters. What is the arc length of the of the circle described by an angle of pi radians to the nearest tenth of a centimeter. Now, one thing that I didn't mention at the very beginning of this video is as I gave students also the arc length formula, which is this. The arc length S equals R times theta, and R being the radius and theta being the angle in radians. And there's another version that involves this formula but for degrees, but I'll get to that later. And so if we have S equals R theta, well, R is going to be 10, and then we have pi, right? Because that's going to be pi radians. So the pi replaces angle here, and that's in radians, and the 10 centimeters will replace this radius here. And so if we work this out, you, I hope, know that pi is approximately equal to 3.14, so times 10 would be 31.4, and so that would be answer choice D. Next, another arc length related problem. The diameter of a large pizza is 14 inches. If the pizza is cut into 8 equal wedge-shaped slices, what is the perimeter of a single slice pizza to the nearest tenth of an inch? Well, here you have a diameter is equal to 14 inches, so therefore you have your radius is going to be diameter over 2, which equals 7 inches. So that would be for starters. And next, we will have, as far as what we need, the perimeter is going to be, I'm just going to write this up here. We know that in a pizza slice, which I'm sketching out right now, you're going to have 7 inches at the bottom, 7 inches at the top, so we're going to have 7 plus 7. And based on that, we already know answer choice A is out of here, and probably D is not realistic either. So, in fact, actually C is out of here too, isn't it? Because you already have 14. So it's going to be answer choice B. Let's go ahead and just get the fine-tuned details on this. What we're going to have for our arc length is we have 360 degrees into 8 slices, and that's going to be 45 degrees. And so we can use the arc length formula, but S equals R theta, but the portion also that converts this theta into radians is going to be multiplied by pi over 180. So in this case we have S equals R, and we already know that R is 7, and we know that we have 45 degrees times pi over 180. And again, it's this pi over 180 that converts this arc length to, of course, the formula to be able to work. So we go to calculator, and we have 7 times 45 times, we have pi over 180. So we get 5.49779, so about 5.5. So we go back here, 5.5. So we add here 5.5, and that's going to be 17.9, or actually 19.5, which is answer choice B. Next, problem 6. In a 30, 60, 90 right triangle, if the short side of the triangle measures 5 feet, what is the measure of its hypotenuse to the nearest tenth of a foot? So if we just kind of sketch out a 30, 60, 90 right triangle like this, and we're given that our short side here is 5. We want to find this hypotenuse on top. Well, for that we can go to our formula chart, and we see for special right triangles for 30, 60, 90 right triangle, we have the sides x comma x squared 3 comma 2x. And in that triangle, x is our short side and 2x is our long side. So if 5 equals x, 2 times 5 is going to be 10, or 10 feet. So our correct answer for problem 6 is A. Should be quite an easy problem. For the right triangle shown below, what is tangent of theta? Well, tangent, I have my little acronym to help remember things. Well, tangent theta is adjacent, nope, opposite over adjacent. And so for this theta here, our opposite is going to be 12. And our 6 here is going to be our adjacent. So tangent theta is going to be 12 over 6, which simplifies to 2, making our correct answer A. Next, for the right triangle shown below, what is cosine theta? Well, cosine, I have that acronym. Some old hippie caught another hippie tripping on acid. So caught is cosine. Another hippie is going to be adjacent over hypotenuse. And that's like SOHCAHTOA. So-ka, right? Ka, C-A-H. And so we have we need our hypotenuse, which is 12. But we are missing our adjacent side. Now, one thing that could be tricky in a situation like this is that if you're not careful about the angle, if you take theta down here, you'll get 9 over 12, which would simplify to 3/4. Not right. We need this side over here on the right, which will be adjacent to our angle theta up above. So to find that, we take the version of the Pythagorean theorem that solves for this, and that's going to be c squared minus a squared equals b squared. And so that's going to be 12 squared is 144, and 9 squared is 81, equals b squared. And so we have 63 equals b squared. So therefore, taking the square root of both sides, b is equal to square root of 63. And so square root of 63 goes here on the right side, which is our adjacent side. And that's going to be square root of 63 over our hypotenuse, which is 12, which is answer choice D. One thing you got to watch out for is that cosine is always going to be less than 1. I mean, a positive cosine will be less than 1. So in this case, C could not be a correct answer. Nor do I believe A could be either. Now, 9, a right angle, if sine theta equals 2/3, what is cotangent theta? Well, in this case, we have 2 is going to be on the numerator here, is going to be our opposite side, and 3 is going to be our hypotenuse. So we can draw a triangle representing those dimensions. So if I go to the right here and draw a right side of a triangle, well, I'll try to get one halfway vertical. Not very good, but good enough. Okay, so that'll be 2, and we know our hypotenuse is 3, so I come over here and make a line segment with hypotenuse of 3, and so your other side is going to be right here. So we have 3 is our hypotenuse. Well, again, our other length, our missing, our adjacent side, is going to be 3 squared minus 2 squared equals b squared. And 3 squared is 9, 2 squared is 4, is b squared. So 5 equals b squared. Therefore, taking the square root of both sides, b equals square root of 5, which is going to be right here. And so our cotangent is adjacent over opposite. So cotangent theta equals adjacent over opposite, and that's going to be equal to square root of 5 over 2, which is answer choice A. Next, in a right triangle, if cosecant theta equals 17/5, what is sine theta? Now this is one of the easiest ones on this test. It's almost embarrassing. If you go here, what do you see about a relationship between sine and cosecant? They are reciprocals of each other. Sine theta is 1 over cosecant theta, and cosecant theta is 1 over sine theta. So they are reciprocals of each other. And that being the case, if sine theta is going to be, instead of hypotenuse over opposite, is going to be opposite over hypotenuse. So this is going to be just switched around to 5/17. So our correct answer is A. Very easy. What is the secant of 2 pi over 3? Yeah, in this one there are numerous ways to do this. If you're not comfortable with radians, you can convert this 2 pi over 3 into radians, into degrees, by multiplying it by 180 over pi radians. And so we get 360 degrees divided by 3, which is 120 degrees. And if you have your calculator in degrees, you can go ahead and solve this way. If your calculator is in radians mode, you can just enter secant 2 pi over 3. Now, in a T-power CX calculator, we can find the secant, but if you don't, you can go ahead and put, instead of this, you're going to get, our answer could be the reciprocal of the cosine of 120 degrees. Okay, but we're just going to go ahead and put secant 120 degrees because our calculator is set in degrees. So we go here to secant 120 degrees, and we get -2. Now, with the special right triangles, we would be able to get this all right as well. We go over here, like 120 degrees is like this kind of rotation. And then you have, since that angle here is going to be 60 degrees, we know that our short side is going to be x, our long side is going to be 2x, but actually this going to the left is going to be -x, so our answer is going to be 2x over -x, which simplifies to -2. What is the tangent of 225 degrees? Now, if your calculator is already in radians, this is just, again, an embarrassingly easy problem. We have about 3 or 4 or maybe 5. We have really easy problems on this test. So we go ahead and put tangent 225 degrees and we get 1. So 1 is our answer, problem 12. Sine theta 13. Sine theta equals 1/2. Find the acute angle theta that satisfies the equation. Well, if you've done the unit circle at all, okay, the unit circle will be like this, and then you're going to have at 30 degrees, comes up like this. At 30 degrees here, you have the cosine value square root of 3 over 2, and the sine value is 1/2. Okay, and this is going to be at pi over 6, which equals 30 degrees. And so, just using that, you're going to be able to get answer choice A. But also, what you can do, if you have an equation like sine theta equals 1/2, how do you isolate this theta by itself? Well, what you do is you can take the inverse sine, and when you take the inverse of this whole equation, you have inverse of sine theta equals inverse of 1/2, inverse sine of 1/2. And so the inverse sine and sine cancel each other, so you get theta equals the inverse sine of 1/2. So you can go to your calculator and go to inverse sine down here, and 1/2, I'll just put in 0.5, we get 30 degrees. Now this is acute angle trigonometry for if you go over to another quadrant besides 1, you have to keep in mind that you could have this is acute angle. You could also have 150 degrees would work for that. Would also have a sine of 1/2. Let's go on 14. If cotangent theta equals 1 over square root of 3, find the measure of the acute angle that satisfies the equation. Give your answer in radians. Well, you can use a special right triangle for this if you'd like. One thing you can look at is cotangent is opposite over adjacent, so we can say 1 equals our opposite, and square root of 3 equals our adjacent. Let's see, opposite over adjacent. Wait a second, it's adjacent over opposite. So I have them mixed up. So our adjacent is 1, our opposite is square root of 3. So we can, if we want to go ahead and put this opposite, square root of 3 again. So our opposite is square root of 3. Our adjacent is 1. And so our other side over here is going to be square root of 1 squared plus square root of 3 squared, which is 3. So that's going to be square root of 4 equals 2. And so, let's see, can we do that using this standard? Yeah, 2. So that'd be like x, 2x. So that's going to be 60 degrees, or pi over 3. Or you can take, like we did for the prior problem, so theta, isolating, taking the inverse, is going to be equal to the inverse cotangent of 1 over square root of 3. and I'll put this in the calculator. You get 60 degrees, I believe. So we go to trig, inverse cotangent of 1 over square root of 3, we should get 60 degrees. Well, 60 degrees will translate into pi over 3 radians. There we go. Problem 15. Solve for the unknown to the nearest tenth. Well, here are the two sides we have. Okay, this is our angle, 58 degrees, and 31 over the side 31 is our opposite. So, to find our equation, the one we have to work with is we have our adjacent side here, which is y, our unknown, and our opposite side, which is 31. So we can go tangent of 58 degrees is equal to our opposite, which is 31, over our adjacent, which is y, and solve for y, or we can use the cotangent. 58 degrees is equal to y over 31. And the second one I like better because we can cross multiply that 31. So 31 times cotangent of 58 degrees is equal to y. So we go to our calculator. It's 31 times cotangent 58 degrees is 19.4 rounded. So 19.4. 19.4, that's your choice D. Next, this one for some reason gave people more fits than anything. What you have is the arc length formula. You're trying to find the angle. So it's going to be S equals R theta. And since we have we're looking for a degree, this formula is in radians. So to take this, we want to find what it is we don't know. So that's going to be our unknown. But that unknown, theta, times pi over 180, this whole thing is going to get in radians. So we can just fill in what we have. The arc of a circle with radius 6 kilometers has a length. So our arc length is 4. Our radius is 6. Our theta we don't know in degrees, and we have pi over 180. And if we just go ahead and divide by 6, we get, so that'll be one thing. And then we can multiply also by the reciprocal of pi over 180, which is 180 over pi. So on the other side, we're going to multiply by 180 over pi. So 180 over pi times 4/6 is going to isolate. See, this cancels here on the right. So 180 over pi times 4 over 6. Okay. 180 over pi and times 4 over 6, which 4 over 6 is 2/3, but I'll just leave it in the original. So we get, round to the nearest tenth, we get 38.2 degrees. So theta is approximately equal to 38.2 degrees. Another way you could do this is just take the original formula. If we just take 4 equals 6, let's say 6x times 180 over pi. If you have a solving feature like I do in my tine-inspire calculator, I can just go ahead and put in, it's called numerical solve. It's algebra 1. And so we have 4 equals 6 times x times, it's pi over 180 pi over 180, and we come outside this equation and put comma x. Should give us the same thing, yes, 38.2 round the nearest 10th place. So we go over here, and since we bubble in this answer, we're going to put in, we don't have to put a plus sign if we have the plus already, so we're going to put in 38.2. And I had some students, I believe, who bubbled in 38.19, blah, blah, blah. Still, in the scoring, I think they will give you credit, even if you didn't round and follow directions. Because this is if you get the thing numerically. Because round to the nearest hundred, 38.197, whatever, would give us the same thing, but this is what it should look like. Next, problem 17. What is the sine of 72 degrees? Now, if you had the sine of 30 degrees, you should be able to get that and know what it is. But for this one, you'd have to realistically have to have some kind of calculator or sine tables to get this right. So we're going to go to our calculator and just put in sine of 72 degrees. And if we're set in radians. So we got, set in radians, we'll get it wrong. Now 0.95. Somebody at the beginning of the test asked me, how can you tell if your calculator is set in degrees? Okay, 0.95 would be it. So we'll just put 0.95. So we fill in the point, decimal point, and we fill in the 9, and we fill in the 5. Yeah, somebody asked me, well, what you do to tell if your calculator is set in degrees, if you just put in your calculator, go and calculate sine of 90 degrees. If you calculate sine of 90 degrees, and you can go check settings, but to me this is an easier way. If it says sine 90 degrees and you get 1, that tells you that you are properly set if you want your calculator set in degrees. Anyway, that's it. Good luck on your future tests. I hope you learned something from this. As always, thanks for viewing.